Hey guys, today we are going to start our new unit. It's called Solving Quadratic Equations. This unit, I promised you that our last unit would help with this one, and that's what's going to happen. So this very first lesson is solving quadratic equations by factoring. So what you learned with factoring, you're going to use with this to actually solve equations. Before, it was just expressions and we were just factoring them out. Now, going to be an actual equation, and we're going to factor first and then solve to see where it crosses the x-axis. That's going to be called the zeros. So with this, kind of switching back and forth. So a quadratic equation, that is a polynomial. Quadratic equation is a polynomial in the form, or is a polynomial equation of degree 2. So the leading or the highest degree exponent is 2. And it can be written in standard form, which is ax squared plus bx plus c equals 0. If you can read my handwriting. Ax squared plus bx plus c equals 0. That is standard form. Standard form is where you always have your highest degree exponent listed first. And then if you have any constants, like that C stands for the constant in this, we're talking about standard form, that's listed last. And equals 0. So like a linear equation, linear, straight line, linear has a highest degree of 1 exponent. Quadratic equations can be solved to determine the value or values of x that make that equation true. So if we were to put a value of x in there and solve, the one that makes that true, or both sides equal to each other, or x equals, that's how we would solve them. Anyway, so we're going to use this first example to see how we can solve them by using a graph. So just by looking at a graph. So Isaiah punts a football. The path of the ball can be represented by this equation, y equals negative 1/2 x squared plus 4x. X is that horizontal distance of the ball. So, right here, this is the horizontal distance. And then y is the height of the ball. So when he punts it, how high does it go? That's going to be that highest point. And then your x is how far he goes with that punt. So looking at our graph, if you're just looking at the graph, how many yards is the ball away from Isaiah when it is on the ground? So when it is on the ground, it's 0 right here and right here. Okay, so it's not on the ground when it's up, at 35. What is that? Maybe like 16 or something. It's in the air still. It's still traveling. It's not on the ground. So 0 and 40, that is how many yards the ball is from Isaiah when it's on the ground. So we got two kind of answers there. And that's just by looking at the graph. That's kind of the easiest way. Another way to find those solutions would be to set y, which is the height of the ball, equal to 0, and substitute those solutions from A, so these right here, into the equation to confirm that they're correct. So what I'm going to do is I'm going to say y is 0. And then for the x, I'm going to put these two answers that we got right here, 0 and 40. I'm going to put those in for x. So if I were to write that, it would be negative 1/10 times, I'm going to use 0 first, 0 squared plus 4 times 0 again, because that's my x value, and then equal to 0. We solve that out and using PEMDAS, parentheses first, so 0 squared is 0. 0 times negative 1/2 is 0, plus 4 times 0, which is 0. It's all 0. So 0 equals 0. So that is true. Next, I'm going to erase this right here. I'm going to do negative 1/10 And then I'm going to use this 40. So 40 squared plus 4 times 40, and then that equal to 0. All right, 40 squared is 1,600. 1,600 times negative 1 over 10 is negative 160. And then, so negative 160 plus 4 times 40. 4 times 40 is 160. Negative 160 plus 160 is 0. So that equals 0 as well. So that is true. Some limitations. So C, discuss some limitations of solving a quadratic equation using a graph. So sometimes you're not going to have a good integer, and an integer is just like a whole number, like counting numbers. So positive and negative counting numbers that do include 0. So some of your answers might be like 1.2. And it's hard to look at a graph and see 1.2 on there. So that might be a limitation when you're trying to solve using a graph. All right, so here we get into the factoring. So if you need to, rewrite that equation in the form of ax squared plus bx plus c equals 0. You'll see some examples of that later on when you might have to do that. But always make sure that it is in that form first. And again, I'll show you. Actually, let me just go on down. I know it's on here. Here we go. So if you look at number 7 is x squared plus 5x equals 14. Standard form is equal to 0, and that constant is on the same side as your x values. So to rewrite this would be x squared plus 5x minus 14 equals 0, because we need to move that 14 over to the other side. Just like when you're combining like terms or putting things on, the same side that you need them, you have to do the opposite. So we would subtract that 14 to move it over and then set it equal to 0. So we'll come back to that later, but I just wanted to show you what that means. And then next you would factor it. So what we did in the last unit. And then use the 0 product property to set each factor equal to 0. So once you have factored it out, sorry, I usually draw my line to make sure it looks like a 0. Once you factor it out, each one of those sets of parentheses, you're going to make those equal to 0. And then you're going to solve. So the 0 product property, if you all remember this, that means that if two numbers, if we multiply them together and get 0, that means either A equals 0 or B equals 0. One of those numbers has to be 0, okay? And then just solve for X. All right, so let's get right into it. Let's start doing our factoring. I'm actually going to see if I can flip this. Nope, that did not work. Because you probably can't see me. Never mind. I was going to try to use this as an iPad. Sorry. Hope I didn't give you guys a headache doing that. I was trying to do it so I could write better, but I can't. Anyway, okay, so let's factor this first. So same thing, sum and product. So we have to find two numbers with a product of negative 10 and then a sum of 3. That doesn't look good with my handwriting. Okay, so negative 10 and then positive 3. So right off the bat, I know that 5 and 2, when we multiply them together, that gives us 10. And then 5 minus 2 gives us 3. So that would be, one of them has to be negative. So that's the negative 2, 5 times negative 2. And then 5 minus 2 gives us 3. So those are our factors. So we've got x plus 5 and then x minus 2. So we factored. Now we're going to set each of these factors equal to 0. So x plus 5 equals 0. And then x minus 2 equals 0. So this is just a one-step equation now. Minus 5, minus 5, x equals negative 5, and then add 2 and add 2. So x equals 2. You all will get good at this and you won't even have to do that step. But I just wanted to show it to you. So that right there, those are your two solutions. So that's where your parabola crosses your x-axis. If we were to go back up to this one and we were to actually expand that out, you would see that it would, come down. If it was with this, you can't have negative distance. When he's punting a football, I mean, maybe if I kicked a football, it would be negative distance, but that's not a good solution. But if we had, let me see. Yeah. Okay. So here's an example. It's where it crosses that x-axis. This is an upside down parabola, but those 2 points on that graph, those are called the zeros. Okay. So where it crosses that x-axis. All right. So for number 3, let's go ahead and do this one. So if you remember, and some of you all on your test forgot that sometimes you might be able to make your life a little easier just to see if there's a greatest common factor. There wasn't one for number 2, so I just kind of skipped past that. But looking at number 3, I know that there's a greatest common factor in both 5x squared and 15x. I'm going to give you all a second, see if you can think of it. Hopefully you all did. It would be 5x. So 5x would go into both of those terms. So we can pull our 5x out. And then on the inside of the parentheses, we can just do x, because 5x times x is 5x squared. And then plus 3, because 5x times 3 is 15x. And then set that equal to 0. So these are both of my terms, 5x and then x plus 3. So 5x equals 0. And then x plus 3 equals 0. All right, so to solve both of these, the first one, we would divide by 5 on both sides, and then x would just be 0. And then if you subtract 3 on both sides, x equals negative 3. How are we feeling? Doing okay? Some water. Okay. Next one. So number 4, same thing. Product and sum. A product of 12. Oops. I keep wanting to write P and S for product and sum, but I don't need to do that. So 12 and 7. All right, I'm going to come back to that. I'm going to give you all a little bit of time to work on that. And then at the end, I'll tell you the answer, and you can go back and check yourself, okay? All right, so number 5, we've got our graph here. So if you all look at C, you could probably see where it crosses that x-axis. And here's an example of where sometimes it doesn't cross at a really good point. So it's kind of hard to tell just by looking at this I can definitely see the positive. That looks like a 3. It crosses at 3 right here. It's kind of hard to see and be fairly certain what that 0 is. So to estimate it, I'm going to say our two zeros are x equals 3 and x equals negative 1.5. So that's my estimation. So I'm going to write x equals 3 and x equals negative 1.5. Okay, so now I'm going to rewrite this equation in standard form, then solve it by factoring. So 2x squared minus 3x minus 9 equals 0. Don't forget, you need to set it equal to 0. So this is one of those where you have to, our leading coefficient is greater than 1. A is not equal to 1. So this is where we have to multiply 2 times negative 9, and that's our product. So product of negative 18, and then a sum of negative 3. And in my head, 6 and 3. 6 times 3 is 18. 6 minus 3 is 3. So I could do negative 6 times 3. And then, negative 6 plus 3 equals negative 3. So those are my two numbers. So I'm going to rewrite it as 2x squared minus 6x plus 3x minus 9 equals 0. And then group these together. And as I'm doing this, I'm remembering that we did that easier way. So if you all want to do it like this, where with your, so remember it was negative 18 up top, and then negative 3, so that would be negative 6 and positive 3. Sorry, my pen isn't working very good. So if you all want to do it that way, I'm going to keep going like this because I've already started and I've committed and I need to keep at it. So I'm going to bring out my greatest common factor of this first one. So that would be 2x and then x minus 3. And then, sorry, this is bothering me. I'm writing terribly. And then my greatest common factor of the next one, let's see, plus 3. Oh, yeah, that's right. And then x minus 3. So my two factors are 2x plus 3, because I'm grouping these two together, equals 0. And then x minus 3 equals 0. Whoops. Did x equals 3. So x minus 3. All right, so this one is x minus 3. So that checks off because that's what I originally thought. And then to solve this, I'm going to subtract 3 from both sides. And I've got 2x equals negative 3. Divide by 2, divide by 2. X equals negative 1.5. So that checks out. Yay, for my original estimation. So that's how, when you can't really see it on a graph, it's kind of easier to just go ahead and factor so that you can get a good, strong number of what that 0 is. Sorry, I wrote into the next one, so hopefully on your paper you'll be able to see it a little better. But it says that Riksha found the factors of a quadratic function to be x plus 3 and x minus 5. What does that mean about the zeros of that function? So that just means that x equals negative 3 and x equals 5. That is where that parabola crosses the x-axis. So let's see, this is, it doesn't show us what the actual equation is. But if it was an upside down or, a right side up parabola, that's where it's crossing over the x-axis. All right, let's go back down. I'm going to go ahead and do number 7, and then I'm going to let you all do number 8 on your own, and then we'll just finish out 9 and 10. We'll be done. Okay, so for this one, same thing, product and sum. So product of negative 14 and a sum of 5. So I know right off the bat, just looking at that, 7 and 2, because 7 minus 2 is 5. And then 7 times negative 2 is 7 times negative 2, 7 minus 2. 7 times negative 2 is negative 14. Sorry, I didn't finish that sentence earlier. Okay, so now I'm just going to factor with x plus 7 and then x minus 2. So x equals negative 7 and x equals 2. There we go. But make sure this was that problem that I told you about earlier. That's why I went ahead and did it. It was already written down. Because, sorry, my husband has the Reds game on and somebody just scored. but you need to make sure that it's always in standard form. So it's equal to 0. That constant is on the same side. All right, so number 9, and I'm going to leave number 8 blank. I want you all to do that on your own. And at the end, I'll come back and I'll give you the answer. Okay, so Ms. Cuthbert asked her students to find the zeros of this function, y equals x squared minus 225. Georgia claims the function will only have one zero at 15. Do you agree or disagree? It says to solve by factoring to justify. So hopefully, I'm hoping that you all remember just by looking at this what this is, what this function is. X squared minus 225. Is 225 a perfect square? Miss Flick, I'm glad you asked. It is, because 15 times 15 is 225. This is that difference of squares. So this would be x minus 15 and x plus 15. There you go. Because negative 15 times positive 15 is negative 225. If we were to FOIL this to check our answer, we would have negative 15x and positive 15x. Those would cancel out, so that's why we don't have that middle term, or that bx term. So this has two answers. So we would disagree because our two zeros would be x equals positive 15 and x equals negative 15. So this is a big old disagree because there are two zeros. All right, so number 10. So I read this to my husband earlier, and he was like, "Are you kidding me? 8th graders are supposed to do that problem?" I was like, "Yes, my smarty pants, 8th graders can do this." But I hate this equation. I sat here and I was working on it, and it just made me really mad that the leading coefficient, or the A, is a negative decimal number. This is like fractions. I don't like this. So what I want you all to do, if you don't have your graphing calculator, get your graphing calculator and just put that in the graph. And then it will show you, or if you don't want to get up and get your graphing calculator, just Google Desmos graphing calculator. Since I'm only doing this one browser tab, it won't record me. Actually, maybe it will. Let me see. It won't. Shoot. Well, I'm trying to pull up the Desmos graphing calculator. Make sure you go to Desmos graphing and literally just type in y equals negative 0.05 x squared plus 6x, and you will see the two zeros. The question is asking, find the horizontal distance that sprinkler covers. So when you put that in your graphing calculator, I want to give you all a second to put that in. When you put it in, and make sure your window is set so that you can see. Set your window of x, or your x value, your x min to be negative 10, and your x max to be 200, and then your y, you can do that as your y min to be negative 20 and your y max to be 50 maybe. But set that up, put it in, and the question is asking, what is that horizontal distance? So it goes from 0 to how far when he does that, his sprinkler. So that sprinkler goes up in the air and it sprinkles his field. What is it? Yeah, his field. So y is how far up it goes, how high it is, just like that punt earlier. And then x is where it lands. So if he's trying to get far away, his tomatoes that are far away, how far of a distance does that water need to travel after it goes up in there, kind of like the punt. Okay, so if you put it in your graphing calculator, you should get your two zeros to be, or where it crosses that x-axis, 0. because that's where it starts. And then your other 0 should be 120. So it'd be 120 feet. Sorry, I should have done my whole browser, not browser, my whole screen, so that I could have pulled up the decimals calculator. But that's the easiest way when it's something like that, because when it's not fractions, decimals and stuff, I don't mess with those. Just get out your calculator sometimes. Okay, so in the interest of time, I'm going to go back. So number 8, your answers, let's see, when I did that, when I worked it out, let's see, x equals -1/2 and x equals -5. Okay, hopefully you all got that. If you didn't, if you haven't tried it yet, try it on your own, and hopefully you'll get to those 2 answers. What was the other one? Oh, number 4. What was that one? Okay, so x equals -4 and x equals -3. There we go. There's your answers. Hopefully you all got that. I hope the project went well. I hope you all enjoyed doing that. My kids last year, they had a lot of fun with it. So I'll be interested to look at your maps. Miss Moser will put those grades in Infinite Campus, but I'll look at them and grade them for her, because I want to see how you all did. Hope everything's going great. I still miss you all. I'm actually recording this Monday night, so you all won't watch this until Thursday, I guess. But don't want to make you all jealous or anything. But tomorrow I'm going to go to all of our different pools at all of our estates to learn how to clean all of them, and the jacuzzis and hot tubs. So that's what I'll be doing tomorrow on Tuesday, which, again, you're watching this on Thursday, so I've already done it. But anyway, I hope you guys have a good day, and that's it. You've got homework from this. It's just some practice problems, just to get you all in the habit, because the more practice you do, the better you are going to get. And that's it. Okay, bye.